Hello everyone, so today's question is called valid mountain array. Given an array of integers, return true if and only if it's a valid mountain array. So what is a valid mountain array? It is basically an array where you will have strictly increasing and then strictly decreasing values. What is strictly increasing and decreasing? This means that values should be increasing till a given point, and then it should decrease. It should not be equal. For example, this one, it should not be like 3 and 3. If there is a case like 3 is equal, if you get duplicate values in adjacent to each other, then it will be wrong. So what will be our intuition? What we can do is that, for example, this is the example. So if we fix two pointers over here and one over here, right? So we are at two ends of the array. Now we know that from both the ends it will be increasing. If I look from this end, this array will be increasing, and if I look from this end, this array will be increasing, right? So what I can do is I can check for as long, like I can do, if I have a pointer I over here, let's say I have a pointer I. Now I'll say increment I till ai plus 1 is more than ai, right? So for example, I'll say that okay, 2 is more than 0, so increment I, so I will come over here now, right? Now again I'll say that increment I if ai plus 1 is more than ai, so 3 is more than 2, so now I will come over here. Now again we see 4 is more than 3, so again I will be pointing to 4. Again we'll see 5 is more than 4, so again I will point here. Now you can see that 2 is less than 5, right? So when ai plus 1 is less than ai, we'll just stop there. Okay, now let's see how this pointer will move. So for example, if I say that let's take another pointer I, or let's say j, let's take another pointer j at this end, at the end of array. Now we'll say that if while aj minus 1 is more than aj, like if this is more than this, then decrement this j pointer, right? So over here you can see j, that is 1 is more than 0, so j will point to 1 now. Now we can see 2 is more than 1, so it will point to 2. Now we can see 5 is more than 2, so again it will move, and now it will point to 5. Now it will check again, and 4 is less than 5, so it won't move and it will stay there. So now we can see that this way we can prove if my I and j pointers end up being at the same place, then it will be true, right? So you can try this methods for this as well. It won't work. So we'll move both the pointers from both ends, and as long as we'll get the incremented values, we'll move, and once we stop, we'll finally return if both the pointers are pointing at the same point. Let's write the code. So let's just take the size as a dot size first, and then I can say int I will be equal to 0 because I want the first pointer to be named I. Now let's just say j will be equal to n minus 1, that is the end pointer. Now while, as we saw, while ai plus 1 is more than ai and now see, this condition will be there. So one thing can happen, that if it's like completely strictly decreasing, right? For example, if your array is just like this is the end of your array, and your array has values 0, 2, 3, 4, and 5. So in this case it will keep on increasing, and it won't decrease, right? So we need to make sure that both the pointers that are at the end don't reach the opposite end. So basically what I'm trying to say is, if I is over here, I don't want this I to end up at the end, and I don't want j, which is over here, to end up at 0th position, right? So I'll say that I should always be less than n minus 1, which is the last position, and I plus plus because we need to increment. Now while a j is less than a j minus 1, again same condition over here, j should be more than 0, then we'll say j minus minus. Alright, now finally what we have to return is, we'll return if I is equal to j. Along with this, we'll say that make sure the conditions are true, that is j is not like, if I is over here, then I should not be equal to the n minus 1th index, and j should not be equal to 0, right? Because in that case it will either be strictly increasing or decreasing, and it won't form in a mounting. So I'll say I should be less than n minus 1, and j should be more than 0. So this will be the answer. We have a runtime error. J should be more than 0. J is n minus 1, and j minus 1 should be I is n minus I, so should be less than n. So I just found the mistake. It's a very interesting and very intricate detail. So if you see, this is the case where we are failing, right? So just take this case. Now our j is at n minus 1, which is it is pointing at this 1. Now it will check if ji minus 1, which is 2, is more than 1 or not. So it's more than 1. Now so it will be decremented. Now j will be pointing to 0, right? Now what will happen is, basically it will, now j is equal to 0, right? Right now j is equal to 0, and now it will be checking something like a j minus 1, and j is already 0, so it will be 0 minus 1 is more than a 0, right? Now this is where we are failing, because we can't have anything index as minus 1, right? So this is where we are failing. So instead of doing this, what we can do is basically make sure that this value, we check this condition first, and then we can go ahead and check this condition. Similarly in this case, we'll check this condition first, and then we can go ahead and check this condition. This won't be a problem if we do for if we are doing like or instead of and, because in or they check the first. No, it will be a problem. So yeah, this was the problem basically. It was very interesting. So yeah, hope you understood the problem, and this problem and the problem that we face.